Assalamualaikum. We are from Group 1 presenting about the topic determination of pressure profile and pressure drop in incompressible fluid of radial flow by using MATLAB script file. Introducing our group members, there is involved by 5 students, which is Hazim bin Haris, Muhammad Daniel Haikal bin Kamaruzaman, Athanasius Anta, anak GTES, Muhammad Rizwan Shah bin Sharul Nizam, and the last one is me, Muhammad Syakiruddin bin Rahman.
Hi, my name is Hazim bin Haris, and I will brief more about the background of this study. Basically, this topic we have choose from the subject Reservoir Engineering 1 that we have learned from previous semester, where this topic we will talking about how do we use Darcy law to calculate certain problem, or how we implement these terms of Darcy law to solve a problem. The fluid is assumed to be a steady state, indicating that there are no changes in flow properties with respect to time. The porous medium is characterized by its own permeability and the fluid flow in radial flow, starting from a center point of a well. The equation below representing the flow rate Q equal to 0.0708, that one in oil field unit, time with permeability, the thickness, and also the change of pressure divided by the viscosity, formation volume factor, and also the change of radius. There are 3 problem statements we have discovered. The first one, to determine external pressure, PE using general equation of Darcy law derivation. Second one, to analyze pressure drop in each depth. And the last one, to determine the pressure profile from graph drainage radius versus pressure. So the picture below, we can see that the reservoir in radial flow. For the engineering problem, we have assumed that an oil well in the west field is producing in a radial flow reservoir at a stabilized rate of 700 Stockton barrel per day, and the bottom hole following pressure is about 1000 psi. The permeability is 150 mD and the thickness is 35 feet, and given the area of 50 acre. And the following data is given for the well bore. The initial for the well bore radius is 0.5 feet, and the formation volume factor is 1.25 barrel per day, and the oil viscosity 2.5 cp. First one, we would like to calculate the pressure profile distribution and to determine the pressure drop across 2 feet interval from 0.5 to 2.5, 5 to 7, 21 to 23, 98 to 100, and lastly 748 to 750.
Assalamualaikum and hi everyone. My name is Muhammad Rizwan Shah bin Sharul Nizam Misri. In this section, I will talk about the script file that begins at the line 1 and ends at line 12. The command known as fprintf allows for the output to be displayed on a screen in the form of text and data, and it also provides the option to save the printed output to a file. When it comes to our project, the fprintf function is used to output data that has been prepared to the command window. This is done solely for the purpose of calculating the pressure profile. By utilizing the second function, which is referred to as the display function, it is possible to display text in addition to displaying the value of a variable without disclosing the name of the variable. In order to construct a loop that is often referred to as the for loop, the for function is employed. It makes it possible to repeat a section of code or to iterate through the elements of a vector or array a predetermined number of times. What approach do we take in order to ascertain the measurement of the drainage radius? A looping structure can be established through the utilization of a while loop. While loops are a type of control flow statement that enable the execution of lines of code in a loop for an extended period of time, provided that a particular condition is satisfied. It is possible to specify the beginning of a code block, such as for loop or a while loop, by using the keyword with the appropriate syntax. For the purpose of determining boundaries and guaranteeing precise execution, this control flow operator is of great existence. Next, line 14 through line 54 are utilized for the purpose of establish a variable that is essential for the calculation of pressure. The bottom hole pressure, permeability, oil flow rate, wellbore pressure, oil viscosity, thickness, and wellbore radius are some of the factors that are included in this variable.
Greetings, my name is Athanasius Anta. So I'm going to explain about my part about the MATLAB script, which is from line 44 until line 88. From line 44 until line 54, it is having the same command, where line 44, the H is the input, which represent the thickness, and starting from line 50, the input is WR, which being represented by wellbore radius. At line 56, we are using the format bank to display the table of calculated data and to display the drainage radius table. The fprint and string command in the line 64 to 70 has their own code or symbol, such as Q, P, K, V, B, H, and also WR. The display command is used to display the element of variable that are displaying the name of variable and to display the text. From line 72 until 74 is being used for the calculation of natural log with the input of radius of a wellbore radius. Line 76 until 79 is calculation of pressure profile where with the data for natural log is at 81 until 88. Lastly, pressure profile data will be tabulated in the second table with the code of PP. It will appear the drainage data and the pressure profile data. It is code where we use the format bank, string, fprint, command, and command division. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh. My name is Muhammad Daniel Haikal bin Kamar Zaman. Now I will continue with the line 90 until 105. For the line 90 until 93 is the data from the drainage radius on the x-axis of the graph, and the line 95 until 98 is the y-axis for the pressure profile. Both common use of fprintf, string division, and format bank. Next, the line 100 until 104 is for plotting the data from our data. Line 101 is used to decide the size of the graph. Line 102 is to plot the x and y point with a solid line and circle marker. The line 103 and 104 is to label the axis with x label with radius feet, while y label with pressure psi. Next, I will continue with the MATLAB simulation to show the data input. We input 10 drainage radius data with the interval of 2 feet from 0.5 feet until 750 feet. Then we also insert the given value, which is flow rate 700 STB per day, bottom hole pressure, which is 1000 psi, permeability with 150 millidalcy, oil viscosity with 2.5 cp, oil formation volume factor with 1.25, barrel per STB. Then thickness 35 feet. And lastly, wellbore radius 0.5 feet. The data is needed to generate natural log. The data will be used in generating the pressure profile table and also be plotted. For the last part of the pressure profile, we want to determine the change in pressure drop of the interval in our data. From the MATLAB simulation, we can conclude that we can analyze the radius interval with the pressure drop. By using the string function, we can input all our data from one interval, which from 0.5 feet to 2.5 feet until the last interval of 748 feet until 750 feet. And then when we input the data, we can get this result. When we run this command, we can see the decrease of pressure drop gradually throughout the bottom hole pressure. This can cause several impacts such as reduce of flow rates, reduce the production of the oil and gas, therefore decrease the productivity of the wellbore. That's all for me, thank you.
Conclusion of this, the MATLAB program provide a quantitative understanding of the pressure distribution and pressure drop in an incompressible fluid of radial flow by analyzing the pressure profile and pressure drop across different radius interval. Engineer and researcher can get insight into the fluid dynamic and optimize the design of the system involving radial flow such as pump and turbine to ensure the efficient and reliable operation. Thank you.